keeping you until 19:30. So have your juices, your water close to you. If you are joining with two devices, Lehakwe, just maybe switch one off. Thank you very much. No problem at all. Ladies and gentlemen, this is what I do daily in order for you to actually follow up in the lesson. A quick summary, and then we add new things of the day. Let's go. We spoke about Newton's laws 1 and 2. 1, focusing on objects that are at rest or stationary or not moving. However, the very same law is now focusing on objects that are moving, but these objects that are moving, they are moving at a constant velocity. I explained this in detail. Constant velocity to us means no acceleration. Acceleration is equals to 0 meters per second. The forces acting on the object are in equilibrium. Whether the object is moving or stationary, forces are always there. So don't be misled or create a misconception that says now what? That says when an object is at rest or not moving, there are no forces. There are forces that are keeping it steady or at rest. Hence we say all the forces acting on the object are at equilibrium. And most importantly, to define Newton's first law, an object will stay at rest or continue to move at a constant velocity unless acted upon by an external force. Other books will say something like non-zero resultant force. Other books, a lot of things, but basically this is the basic one that we are going to work with. We associate Newton's first law with inertia as the resistance of an object to change in its state of motion or rest. We also explained that mass is a factor that influences inertia. The bigger the mass, the more difficult it is to move an object. We then related first law into how it assists with now what? With safety belts and explaining other factors of our daily lives or daily living. Safety belt, what do they do? Increase the contact time between the passenger and the dashboard. By doing what? The net force is reduced or decreased and the passenger will become now less injured. Then I came up with this problem of Michael Schumacher to say the road is wet. He's failing to control the car. It keeps on moving. What could be the reason? There is no external force, which is a frictional force that opposes the motion of the object, which is parallel to the surface. That definition is important for all of us to know. Let's move. Newton's second law. When a net force is applied to an object, the object will accelerate in the direction of the net force. Acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Ladies and gentlemen, this law, all laws are important. 1, 2, 3, and 4. But law 2, I don't know another way to emphasize how important it is. It is very, very important. Why? Because it has calculations based on it. The application of Newton's second law is more than of Newton 1, Newton 3, and Newton 4. Very, very, very important. So it means now there are things that you must add into Newton's second law that will allow us to make our job now very, very easy to understand the concept. Hence, ladies and gentlemen, I said I am going to extend this session until 1930 for the purpose of explaining all the critical important things. Maybe if time allows, we might just as well also expose ourselves to a problem or an activity that will assist us. I then created a nice short summary of differentiating between Newton's first law and Newton's second law. This is a summary to assist you to actually say, obviously all the laws you must be able to state, but these bullets here, they assist with what? With the application. These bullets here, they assist you in terms of the approach. The only thing that I did not do here was to say F net is equals to MA, which is now the equation related to Newton's second law. Lehakwe, questions please.
Sorry, I'm fine so far. I went through this now before the class, so
Thank you very
so
much.
far I understand.
Thank you very much, Lehakwe. Your Excellency, Mr. Mazibuko.
Nothing so far, Okora.
Thank you very much. Ladies and gentlemen, let's move. There's this bullet here that is written NP. This bullet says identify all forces acting on an object. Now, let's start from grade 8. Number 5. At number 5, we say contact and non-contact forces. These are things that you should have done grade 8, grade 9, and maybe a little bit of grade 10. I think so. I don't know if you've done them, but let's explain what is that. Contact forces arise from physical contact between two objects. Non-contact arises even if two objects do not touch each other. Very important. Physical contact between two objects. Two objects do not touch each other. We are going to need examples of those. examples of those. Contact forces, they arise from a physical contact between two objects. Let's start. Kicking a ball is a contact force. Why is it a contact force? Because the force is applied between the ball and your feet. And we can also say frictional force, or when you rub your hands together creating that friction, is a contact force. So we can say force applied frictional force. We can say also normal force. Let's stop there. Non-contact. If you have two magnets, you know this from grade 8 also. Magnet. This magnet keeps pushing the other magnet away. There is a force here, but the magnets are not touching each other. What do we call that force? Anyone, Your Excellency? When you have two magnets and you are trying to bring them close, but they are not going to. Yes, Lehakwe?
It's called a magnetic force.
It's called a magnetic force. That magnetic force, because they are not touching each other, that magnetic force, it is now a non-contact force, because the magnets don't necessarily need to touch one another. But you can see there's a force because they are not coming towards each other. When you have an apple, and then you throw it up, it will come down and hit the ground. But when it is now at A to B, there is a force pulling it down, because it is no longer in your hands. You throw it up, but it is coming down now. It means there is now another extra force that is making this particular apple to come down. Can anyone assist in terms of what is the name of that force?
Is it gravity?
Thank you very much. We call it now gravitational force. So gravitational force, the force does not have to be in contact with the apple. However, the apple will still come down. So that force, ladies and gentlemen, we call it a gravitational force. That gravitational force is also a non-contact force. Ladies and gentlemen, these are enough examples of contact and non-contact. But for our grade 12 content, grade 11 content, we are going to work with force applied, frictional force, normal force, gravitational force. Magnetic force or magnetic field, as most people call it, we are going to look into it when we do electromagnetism. That is now other chapters as we move towards completing the syllabus. So all these forces, force applied, frictional force, normal force, gravitational force. Ladies and gentlemen, these are critical forces that you must be able to fully understand. Let me give you your 10 seconds. Sorry, it must be 50 seconds. Let me give you your 50 seconds to digest everything on this particular slide, and then we can basically move to another concept. Ladies and gentlemen, thank you very much. Let's move. Now, we must know the forces that we are working with. Let me start by saying at number 6, we have now a normal force. Things are getting now more interesting. Serious science. Ladies and gentlemen, because it's part of the forces that we are going to use, it is very, very important. It is defined as the force or component of a force which the surface exerts on an object with which it is in contact and which is perpendicular to the surface. I repeat, this is very, very important. Most people were shocked in the previous years when examiners were asking learners to define a normal force. It was debated at the level of DBE, and it was there in the CAPS document. So all definitions that are in the CAPS document are examinable. So I don't want to say to you, study this definition, it's not important. All definitions are important. It depends now on the examiner. Ladies and gentlemen, let's understand what is happening here. I'm going to draw a table. And in this table I'm going to put a small onion block. Let me fill it with yellow. It's fine. Remember, we said we have, even if it's sitting on the table, and this is now a block. Remember, we said there are forces acting on the block. Let's understand this definition. The force or component of the force which the surface exerts. So this force, ladies and gentlemen, it is not exerted by the block. It is exerted by the surface. Our surface is here. This here is our surface of the table. So this force, which is the normal force, it is the force exerted by the surface on the object. So when we draw, it means this force, it must start where, ladies and gentlemen? This force must start on the table. But this force, it is in contact with the block, which is perpendicular. Mr. Mazibuko, perpendicular, meaning please. Meaning of perpendicular, ladies and gentlemen?
Sorry, what was the question? Again, meaning of the perpendicular.
Yes.
Isn't it basically when what two objects intersects themselves, or
Okay. Lehakwe?
Perpendicular basically means when there's a 90-degree angle between two objects.
Thank you. It means between the surface and the block. Thank you. We are going to have that 90 degrees. So it means this will be our force acting upward. And this force, ladies and gentlemen, we call it force normal. So when we draw it completely, we will take an arrow and indicate that we have a force starting there, moving up, and this force is called F normal. So F normal, ladies and gentlemen, basically means it is a force applied by the surface on the object. Very, very, very important. So it means as long as the object is on a surface, we are going to have now what? A normal force. Now, let's check. If we have F normal, the block, let's go back to the apple. Mr. Mazubuko, you said block or the apple will move up and come down because of gravity, ne?
yes,
Can I say if the apple is here, there's a force pulling it down, ne?
yes,
And what is the name of that force? We agree to say it is the force of gravity, ne?
yes,
Fg. So all the objects on Earth, they experience now what? Force of gravity. So even when this object is sitting on the table, it is now possessing what? Force of gravity. Because it has its own mass. Now, ladies and gentlemen. So by so doing, it basically says, indeed, there's another force there. Now, that force, we are going to call it number 7. Number 7, it's now gravitation. gravitational force. Fine. Gravitational force is a downward force that acts perpendicular to the object with a gravitational acceleration of 9.8 meters per second squared. So we are introducing our very first constant. G is equals to 9.8 meters per second. Fine. Now, what does this mean? It means the formula for Fg is equals to mg, where now m is the mass and then g is now gravitational acceleration, and mass must be in kg, and this is now a force of gravity. Fine. 100%. So let's draw a block sitting on the ground. Fill it with yellow also. Now I want us to say there is a gravitational force acting on this object. What is the direction of the gravitational force? It is downwards. So this we call now Fg. Some people usually use Fw, but the W must be small. So this is the ground and this is now the block. Now, ladies and gentlemen, we have explained two important concepts. I want to link the two into one. Allow me to do so. I am going to take this and that to create a junction here to say we said when working with Newton's second law, free body diagram is needed to identify all forces acting on the object. So we have identified one force. So when we draw a free body diagram, we start with a huge dot, ladies and gentlemen. Okay, let me do it right. You start with a nice dot. Let's fill it with red, it does not matter. And then you take your arrow. And then you take your arrow. And then we put labels. We said the one going to the top is F normal. The one going down is FG. Ladies and gentlemen, this thing here is what we call free body diagram. but I'm using the concept of normal force and the concept of gravitational force. So now, let's go back. Newton's first law. Because the object is at rest, F1 and F3. F1, which is normal force, F3, which is Fg. We did not say Fg, F what in the beginning. We just said F1, it is the force that is now, if you pull it up, the object will move up. We said F2 is the force that if you pull it down, the object will go down. But the object is neither going up or down. It is just now stationary there. It is in contact with the surface. We did not know that. Now we're introducing the names of the forces. The force that will act upwards, it is now a normal force. The force that will act downwards, it is now what? Fg. Most importantly, we can conclude to say F normal is equals to Fg. Very, very important. Questions, Lehauke, please. Between normal force and gravitational force.
No, I'm fine so far. I understand.
Thank you very much. So the free body diagram, we are going to use it moving forward, but we need to know how to draw a free body diagram. Mr. Mazibuko, inputs, suggestions on normal force and gravitational force?
No, nothing yet. I completely understand everything.
Thank you very much. If you completely understand everything, then ladies and gentlemen, let's move to another force. Another force is number 8. It is number 8. It is frictional force. Fine. We define frictional force as the force which opposes the motion of an object. Yes, Neo?
Sorry, sir. I was about to ask, for the free body diagram, what would be the units for them, or is there really no unit?
There are no units, it's just the identification of forces.
Okay, thank you.
So we are just using it for identifying the forces. But maybe I should go back. When you calculate Fg, because it is a force, obviously the SI unit must be newtons with a big capital letter N, because it is a force, which is already something that you are doing in vectors at your school. So let's go to the frictional force. The force which opposes the motion of an object which acts parallel to the surface. I'm going to draw that table again, or let's have an object lying down. Object, let's have a block, fill it with yellow for consistency. Now, ladies and gentlemen, let's assume that this block direction of motion, it is moving to the right. Now we are going to attach or try to understand this definition. Is the force that opposes the motion of an object. So it means if the object is going to the right, frictional force must go in an opposite direction, and it must act parallel to the surface. So if this is the ground, it means if this object is moving in that direction, then friction must be moving in an opposite direction. At the very same time, friction must be parallel to the surface. Now maybe we should understand, what does the word parallel mean? What does the word parallel mean? Now, parallel, grade 8 mathematics.
Basically, a side by side of basically the same distance, but just opposite directions. I'm sorry,
No problem at all. Side by side, I will accept. But what it basically says is, if we have our ground there, then friction will be moving into this direction. That will be now our frictional force. It will be parallel to the surface. Most importantly, it opposes now the motion. Let's quickly create a table. Now, we have two different types of frictional force. The first one is what they call static frictional force. The second one is what they call kinetic frictional force. All these are types of frictional forces. Kinetic frictional force. Now, let's understand, is the force acting parallel to the surface? And opposes the tendency of motion of a stationary object relative to the surface. Maybe let me immediately write down the kinetic frictional force. The force acting on the force acting parallel to the surface and opposes the tendency of a moving object relative to the surface. Let me explain, ladies and gentlemen. Keywords: static, kinetic, moving, static, stationary or at rest. So when the object is stationary and is not moving, stationary, not moving, we have frictional force that is keeping it not to move. That frictional force, we call it static frictional force. And we define static frictional force as now what? The force acting parallel to the surface and opposes the tendency of the motion of a stationary object. So it is parallel to the surface, opposes the motion, but for what? For a stationary object. And we have a symbol for that. We call it Fs. So Fs is a symbol for static frictional force. So we have friction, but we have two different types of friction depending on what? Depending on what is happening to the object. So if the object is stationary, not moving, we say it possesses static frictional force. But if the object is moving, there's still friction, because the car is moving on the tar road, ladies and gentlemen. So there's a friction between the tar road as well as the tires of the car. But friction is there, hence the tires will worn out at some instance. Then we say it is the force parallel to the surface, opposes the motion, but of what? Of a moving object. And that we call it now what? Kinetic frictional force. And we say we have a symbol for that. And please note all the symbols. They are very, very important. Fk. Fk, it is now a nice symbol. Nice symbol. Your Excellency, Mr. Mazibuko, questions please on frictional force.
No, nothing yet. I understand everything.
Lehakwe,
I'm also fine.
thank you very
Thank you.
much. Now, ladies and gentlemen, let's have our object. Fill it with yellow. Now, it is moving. Direction of motion. direction of motion. And we agreed this is the ground. Now we must draw a free body diagram. It is moving forward, but how and why I don't know, but the assumption here is it is moving forward. My question is, Lehakwe, how many forces do we have here?
We have frictional force, and then we have normal force as well, and gravitational force.
So it means we have now three forces: gravitational force, normal force, and weight gravitational force. However, because we said it is moving, we must be specific now. Yes, it has frictional force, but the examiner is telling us that it is moving. So the fact that it is moving, we must commit to say it has kinetic frictional force. If it is stationary, then the examiner should be looking for Fs or static frictional force. That is now the difference. If we are not told the direction of the motion or it is moving, then it means we will not be able to draw a correct free body diagram. Now, I'm going to draw a free body diagram. So we agreed that I am going to have three forces. All the arrows, ladies and gentlemen, they must start and touch the object. And then I can put my labels. We said normal, it's F, capital letter F, capital letter N. We said F, G, small g, and then you have the 2. Then we agreed that because it is moving, it means there's frictional force. Frictional force opposes now motion of the object. Then we say this is a frictional force. We agree. But because it is moving, ladies and gentlemen, we call this thing Fk. Fk, why? Because the object is moving. The kinetic friction or the friction that is there, it is the kinetic frictional force. The force acting parallel to the surface and opposes the tendency of an object that is moving. So these things are critical. In an exam, if you write let me save this thing, sorry guys, such that maybe we do not lose the work that we have done so far. If it crashes, then we can be able to go back. If you write this in an exam, F, small letter F, that is now frictional force, we will not give you a mark. That is the common mistake that people will do. We will not give you a mark. The reason of not giving you a mark is the direction of motion is given. So it means the examiner is saying this object is moving. You understand? So the fact that the object is moving, then it means it cannot have static friction. He is asking or assessing whether we are able to differentiate between static frictional force and kinetic frictional force. Clear, ladies and gentlemen? I believe so. Let's move to number 9. Number 9, we call it now applied force. And there is no standard definition, ladies and gentlemen. There's no standard definition, so I don't think, or I know that it will not be asked in an exam to say define what is this applied force. It's just me trying to explain applied force to you. It is the force applied to an object as a push or pull. Full stop. We are going to have our object, fill it with yellow. Now I'm going to apply this force, and this force I'm just going to call it pulling force. Ne? So it means we now have what? Direction of motion as well. You are see now, because we have this boy pulling this object. So there's a pulling force, but this pulling force that you know from grade 8 and 9, in grade 11 we call it force applied. Why? It is applied by an individual on the object. Hence I said it is it is the force applied to an object as a push or a pull. So you can pull, you can push. It will depend now on different scenarios. If you push, something else. If you pull, also something else. But that is now very, very, very important to understand. Now, ladies and gentlemen, now how many forces do we have here?
I see 2 forces. Should I name them?
You see how many?
2.
Which is a 1?
I see gravitational force.
Okay.
I see applied force, and I see kinetic force.
Kinetic frictional force.
Sorry, kinetic frictional force.
That is now number 3. You said pulling force, gravitational force, and then kinetic frictional force. So you see
Yes.
3.
Yes.
Let's say, Lehakwe, how many do you see?
I also see 3, the same as me was saying.
Okay. Ladies and gentlemen, you cannot have gravitational force and not have the normal force. The normal force and the gravitational force, they are blood and sisters, blood brothers and sisters. If you say gravity is there, normal force must be there. Why? Because normal force is applied by the surface. If the object is sitting on the ground is applying that normal force. The object will have now what? It's Fg. So automatically, when the object is sitting on a surface, automatically there are 2 forces. Normal force applied by the surface. Fg applied by the mass of the object. So without any hesitation, I'm confidently going to say noma kanjani, because I have the surface, I have the mass of the object. Automatically these two forces must be there. Clar. I'm not going to negotiate with anyone. I know, because this one, which is Fn, is applied by the ground. This is the ground, ladies and gentlemen. I know Fg must be there. It is applied by what, ladies and gentlemen? It is applied by the mass of the object. Hence we said Fg is equals to mg. The mass of the object. So already we see we have now a pulling force. We have now a frictional force. Fine. Now let's check the size of my arrows. I tried to make Fn and Fg equal. Why, ladies and gentlemen? This object is not moving up, this object is not moving down. It is what? Tucked on the ground, but it is moving. It is moving into which direction? In the direction of the force applied. Capital letter A. So force applied is bigger than Fk. Why is it bigger? Because of the direction of motion. So the direction of motion, it is telling us that the forces that are moving in that direction are now what? Bigger than forces opposing the motion. Ladies and gentlemen, questions, inputs, suggestions, please. Let's start with Lehake. Suggestions, inputs.
I'm slowly understanding. I see my mistake. I see where I got confused. But yeah, when you explain it again, I understand now better.
Okay. His Excellency Neo.
Oh, I have no problems. I understand everything.
Okay. Now, I'm going to try and do something, I want to say simple and complex. Calculating frictional force. Now that we are able to draw a free body diagram, ladies and gentlemen, what's the word? This is science. For now, we are drawing for horizontal and everything, but we are building up nice concepts towards more complex problems. Please, free body diagram is important. We are going to use free body diagram for all our calculations. When we do exam type, I will give you a hint to say how to cheat the examiner, to say how many forces do you actually have to draw. There's always a hint in the examination itself. Now, we need to calculate frictional force. Let's say without using Newton second law. So we are going to calculate frictional force without using second law. What am I saying? I have introduced you to equation number 1. F net is equals to ma. That is the equation of Newton. I have introduced you to the equation of Fg is equals to mg. That is now calculating the gravitational force. Then we spoke about 2 different types of frictions. Applied force. Now what we want to do, calculate frictional force without using second law. Fg is equals to mg. Equation number 1. Fk is equals to mu k F normal. Mu k is known as what? Coefficient of kinetic friction. It's just a coefficient. And what is a coefficient? Let's say depends on the type of surface. So the higher the coefficient, the more rough is the surface. Let's just keep it like that. Now I am going to give you an example. Surface, object, and we say this object weighs 5 kg. And we are told that mu k is equals to 0.1. Maybe I should say also no SI unit. Ladies and gentlemen, and the question comes now. Calculate frictional force. Calculate frictional force. I want to make it 10 marks because what can I see? Let's say we have the direction of motion. But we don't have an applied force. Yes, Lehakwe?
So I just wanted to ask, with math, if I'm correct, with math, the SI unit is different in chemistry and physics. So I just wanted to know which SI unit will be using for this topic.
Okay, let's just say in paper 1, which is physics, grade 10, 11, and 12, we will be using kg. In paper 2, grade 10, 11, and 12, we will be using grams. Does that answer your question, lady?
Yes, thank you, sir.
Thank you. So as long as it is paper 1, everywhere, regardless it's a new topic, what's gonna come, believe you me, the mass must be in kg. If it's chemistry and it's complicated stoichiometry of grade 11, what, the mass must just be in grams. Finish and class. Now, Mr. Mazibuko, this question looks very difficult.
Yes, I agree.
It looks
Yes.
very difficult. Calculate friction. And I'm tempted. I want to make it 10 marks. Let's make it 10 marks. Let's make it 10 marks. The question is, where do I start? Where do I start? Ladies and gentlemen, you must always start by having a free body diagram. So I'm going to draw a free body diagram first. I know I have Fn. I know I have Fg. I know that there must be force applied because it is moving. I know I must have my Fk. So the examiner will give this thing 4 marks. So it means the other 6 is now based on the calculation. But what is it that the free body diagram is telling me? The free body diagram is telling me that Fn is equals to Fg. Why? Because this object, ladies and gentlemen, it's not moving up, it's not moving down, it's moving horizontal. So everywhere where I see Fg or Fn, I can substitute Fn with Fg. Why? Because, ladies and gentlemen, according to the free body diagram, according to the drawing of the diagrams, we understand that Fn and Fg are equal. Why are they equal? The object is not moving up, because if it was moving up, it will mean Fn is bigger than Fg, and then this object will be floating over the ground. So I can easily say Fg is equals to, the formula will be given, don't worry, don't memorize these formulas. Mg, then Fg is equals to 5 kg multiplied by 9.8. Then I can take my calculator. Remember 9.8, gravitational force, gravitational force, or sorry, gravitational acceleration. I'm trying to open up my calculator this side. Gravitational acceleration, which is a constant, 5 multiplied by 9.8, it gives us now 49 newtons. But that is now what? Fg. But the free body diagram informed us that Fg is equals to Fn, which is equals to 49 Newton. So I will not be able to conclude here. Why? Because, ladies and gentlemen, I did not apply the correct principle. So the correct principle is free body diagram informs me in terms of which forces I am going to use in my calculation. In a simple practical exam or a test, before calculate friction, the examiner is going to say, draw a free body diagram to break it down. But because I'm elevating your thoughts and enhancing the concepts, the question was, how do we tackle these 10 marks? If you do not have the free body diagram, I am showing you the importance of getting the correct free body diagram. When we get to Newton's second law, because the object will be moving, we will still need this free body diagram. So if your free body diagram is incorrect, everything will collapse. So now I know, or I have seen in my formula sheet, that there's another equation. Now let me write it in purple. Fk is equals to mu k F normal, which is just 0,1. It is given there, mu k. We calculated our normal force as 49. Then we can easily say 49 multiplied by 0,1. This will give us something like 4,9 newtons. That is now frictional force. You see, if it wasn't of the free body diagram, that okay, fine, I need to link, because the only equation to calculate frictional force is Fk is equals to mu k F normal. So I was given this one, but I still needed to get Fn. So for me to get Fn, what must I do, ladies and gentlemen? Very easy. I must apply the concepts of a free body diagram. I must apply the concept of what information is given. So from the information that is given, Fn and Fg are equal to one another. Them being equal, so if I can calculate Fg, I can easily get the F normal. Use the correct formula, substitute, and get the final answer. Then it becomes now what? 10 out of 10. Only if I have applied the correct principle of using what? The free body diagram. Ladies and gentlemen, they are going to try and trick us by giving us a lot of information. But if you can filter that information into the correct free body diagram, believe you me, we are home and dry. Why am I saying we are home and dry? This topic is based on a free body diagram. If your free body diagram is wrong and you are not applying the concept, ladies and gentlemen, our lives are doomed. Now, His Excellency Mr. Mazibuko, we will stop here today. I want you to go and digest everything of the applied force, everything, calculation, this calculation only. I will not add anything. We will build from next week as we continue. But if you have any questions relating to whatever that you're currently doing, feel free to contact me. I want you to give us a reflection of today's lesson. It is your lesson number 2. It is also Lehake's lesson number 2. So, Your Excellency Neo Mazibuko, please give us now the feedback of today's session.
The session today was actually nice because it blew my mind, the fact that these calculations are so different, and the way that you explain the exam questions is just amazing to me. And it's also nice seeing someone like me also join the call. Makes me doesn't feel alone. But yeah, I actually enjoyed today's lesson.